Hello, everybody. Today's lab, we are going to be talking about a little teeny bit of statistics, and we're going to be focusing on graphing, what parts of the graph mean, as well as how to make a graph in Google Sheets. So the graphs that we are going to do in chemistry, 99% of the time, they're always going to be scatterplot. Now, a scatterplot shows the relationship between two sets of data. And on the y-axis, we always have the independent variable. The x-axis is the dependent variable. We never do a dot to dot and connect the lines. We never do a bar graph. We set up the graph, and then we do the scatter. Now, an example of some data here is ice cream sales versus temperature. So the ice cream sales is going to be the independent. The temperature is going to be the dependent variable. And so down here, we have the scatter plot. Now, what we're going to do is we're going to focus on graphing on Google Sheets. We're going to do one hand-drawn graph with one of the next labs. And then primarily, we're just going to use Google Sheets to do this because using a spreadsheet program is significantly easier than hand graphing. And it gives us a lot better values when we do start to draw our trend line. Now, with this scatter plot, we can very easily see a relationship that with higher temperatures, we get more sales in ice cream, which obviously is a logical conclusion to summer selling more ice cream. Now, once we have the scatter plot, what we often do is we do a line of best fit or a trend line. And the computer does a significantly better job than if we do a hand-drawn trend line. Now, what happens is the computer does this mathematical calculation, and it puts a line in that best represents the data. And it sort of evens everything out. It does this calculation, and the line goes through as many points as possible and represents as many points as possible. Now, why we want this trend line, which is we're going to get to a little bit later, is it gives us a mathematical formula for the line, which allows us to get more information out of the graph. Okay, so now here is another example where we have a plot of sea level rise versus year. So here's all the data, and then here's a trend line. Now again, with the trend line, it allows us to do something called interpolate and extrapolate. Now inter means between. So an interpolation allows us to figure out a value that wasn't tested. It's impossible to test the infinite values in between two data points. But what it allows us to do is to make a prediction in between data points. So we have some data points at about little 19.5 degrees, and we have a data point at 22 degrees. Well, what if the temperature is 21 degrees? Well, we can use the 21, we can go up till we hit the line, we go over, and we can make a prediction that we're going to earn about $480. That's interpolation. Now, extrapolation is where we go outside the data range. And so we only tested up to 25 degrees. Well, what if it was 29 degrees? Well, maybe we would earn about $740. Now, we do have to be careful with extrapolation because it can give misleading results because we are assuming that that relationship, that this linear line continues way beyond the data set. And maybe it doesn't. And there are specific examples in chemistry, particularly when we get to something called Beer's Law in college, which has to do with the absorbance of light. It's only a linear relationship over a short period of time. And then after that, it turns into a curve. And so you can't extrapolate very far beyond the data set. So you do have to be careful because extrapolation means you're in quote unquote uncharted territory. You're making predictions on data that you have never collected. Now, throughout the year, we're going to be working with trend lines and we're going to be looking at the slope. Now, we are going to be calculating a slope by hand. There is some background information here on slope. I'm going to hold off on this conversation till the next lab where we actually are going to be drawing a graph by hand and calculating a slope by hand. But just the things to remember, you do not count boxes and you do not use data points. You always use points on the line. We're going to come back to this a little bit later. Okay, once we have the graph, we can get a formula for the line. And the formula for the line, whenever possible, we want to have a straight line. We do not want to have an exponential curve. We do not want to have an x squared, x cubed. A linear line makes life really easy because we end up with a y equals mx plus b. So y is the y value. 33 is the slope. X is the X value. And then B is the y-intercept. Now, once I have this formula, y equals mx plus b, I can plug my X value in, calculate my Y value, and it gives me a much more precise value rather than just, come back up here, just reading the point. Because coming across, I'm estimating that it's about 740. But when I plug it into my formula, I actually get 741. So the mathematical relationship allows me to plug the numbers in and calculate a precise value. Okay, now two things that I want to talk about: correlation and R squared, or goodness of fit. Now, correlation, co meaning together, is when the two data sets, so when we look at the Y versus the X, when they have a link, when they're connected, when they're correlated, we say they have correlation. Okay, I just used the word twice, one word to define the word, you never do that. But anyway, so this is a perfect positive correlation. Now, positive means I increase one, I increase the other. Okay, this is perfect because everything's right on the line. Clearly, if I increase the X value, the Y increases. A correlation of 1 means the data fits perfectly to a trend line. The closer the value is to 1 or -1, the better the correlation, the better the relationship between the two data sets. Now, this would be a high positive correlation, a value of 0.9. Okay, so they're clustered along a trend line. This 0.5 is kind of meh. It's really not that great. No correlation, they're all over the place. And now we flip the other way. So if it starts to go down, we have a negative correlation, which means I increase the X, the Y value decreases. This is a perfect negative correlation. Okay, now coming down, these are just more examples of negative correlation, positive correlation. But here, a correlation between, this is number of children or birth rate versus income. Higher income tends to correlate to less children. Okay, and that's a negative correlation. And it's probably a medium correlation here. It's not a super strong, but it does come down, and we do have a trend line. It's probably actually more of a curved trend line here. So it says, no, we tried to fit a straight line, but maybe a curve would be better. Okay. Now, correlation coefficient, I briefly talked about. 1 is a perfect relationship, a perfect linking of those two data. -1 is perfect as well. 1 is positive, we have an increase in slope. 1 is negative, we have a decreasing slope. And if we have a correlation of 0, it means there's no relationship whatsoever. So again, positive correlation, no correlation, negative correlation. Okay, now what we're going to get to, and this is what we're going to use all year whenever we make a graph on Google Sheets, is something called R squared, which is called goodness of fit. Okay, it's basically how well does the best fit line describe the data. Excuse me. So what it is, it basically, here's the best way to describe it. It demonstrates the percentage of the data that's represented by the trend line. Okay, and we're going to look at some values and we'll see what that means. So you basically take the correlation coefficient R, you square it, and we're going to look at a decimal value anywhere between 0 and 1. So if we have an R squared of 0, the trend line represents none of the data. If we have an R squared of 100%, or exactly 1, it explains everything about the data. The better the R squared, the larger the R squared, the closer to 1, the better the trend line fits your observations. So let's look at this. R squared, this is 0.15. So what this means is this trend line represents 15% of the data. And the other 85% is due to error, it's due to non-correlation, it's due to other issues. Here we have an R squared of 0.85, which means 85% of the data can be explained by the trend line. Now, a difficult thing is, what is a good R squared? It depends, and the answer is it depends. There is no such thing as a good R squared for all situations. For the labs that we are doing, we're looking for an R squared as close to 1 as possible. And we look at that by saying how many 9s there are. So usually it'd be like 0.98 something, that would be 1 9. 0.99 something, that's 2 9s. 0.999, that's 3 9s. The more 9s you can get, the better it is. So when we're collecting quantitative data where we know the data correlates and has a high correlation, we should be getting R squareds that are super, super high. Now, when you're dealing with qualitative data, particularly with sociology, with psychology. An R squared of 0.5 is fantastic. I mean, the fact that you could get some goodness of fit to that high of a level is phenomenal, because you're dealing with surveys, you're dealing with qualitative observations, and you have to get hundreds and hundreds and hundreds, if not thousands and thousands, of surveys and observations in order to come up with that relationship. Okay, now one thing I want you to keep in mind, and this is going to come into play throughout the year. Your teachers are going to say things to you like, remember this for the rest of your life, or tuck this away in your brain. And this one is something that I want you to always remember. Correlation is not causation. And I'm sure you've heard this before. Just because two things are correlated, just because two things have a strong relationship between the two, doesn't mean that one causes the other. So for example, we have higher ice cream sales in warmer weather, right? Okay, that one causes the other. But we also have more shark bites in warmer weather. Okay, I'm sorry, I reversed that. We also have more shark bites with higher ice cream sales. So we can say that increased ice cream sales correlate to more shark bites, but they're not caused. The cause is, for both of them, is the same thing. The warmer weather means people are in the water, they're buying more ice cream. So of course there's a correlation between the two. Now, as you go through life, you should have a healthy skepticism of data and information that is presented to you. So what you should do is always look at this data that's given to you and go, well, is it correlated, or is there a causation between the two? Because they can lead to different types of conclusions. Okay. This is what you're going to have to do today. And so here's some rules for graphing a scatter plot. So what you're going to do is you're going to pull up some data on a website, and then you are going to graph that data. You're going to graph a positive correlation and a negative correlation. But we're going to use some rules. And the rules that you're learning today, you need to use all year long. And if you don't use these rules, you're going to get dinged and you're going to get points off for your graph. All right. So independent is always plotted on the X, and the dependent is always plotted on the Y. I think I said that reverse up above. Okay, so it's always independent on the